Good morning to one and all present here. Today we are going to discuss about the important topic of application of integration, that Green's theorem, Stokes theorem and Gauss divergence theorem. See, basically the application of divergence theorem, see that using the fluid dynamics and electromagnetism and heat flow. See, in this calculate the net outflow of a fluid from the region identifying source and the sinks within the flow, and also electromagnetism. See, to relate electric flux to charge density using Gauss's law in electrostatic for electromagnetic analysis. See, basically in this magnetism, it's a flux to charge the density using Gauss law. That is a very important thing. And then heat flow. See, in this divergence theorem, so using in the heat flow, how heat flowing, then how to better to do that, very perfectly will get the value. So that we have to use in the divergence theorem, it will be perfectly, it will come. See, that heat flow to determine the net heat flow across the surface. This helps in thermal magnetism management and design optimization. Usefully that it will be a heat flow, it is using in the thermal engineering. Because of thermal engineering, they are using the various places in heat energy. So that will help the divergence theorem. Then the Stokes theorem, that the calculation of curl in 3D. See that the divergence is the dot product and the Stokes is a cross product. So that we have to do that curl in 3D, 3 dimensionals. These are the 3 steps are there here, that the Stokes theorem that connected to the line integral around a closed surface C to the surface integral of the curl of the vector field over the surface S bounded by C. See, in this statement is very, it's a very important in this line, because of line integral to use in the curved surface area, that the around a closed surface C, then the curl of F, the vector field over the surface area. That we have to use the formula, that integral over closed surface of integral over F vector into dr. F vector into dr is equal to double integral S into del cross F vector into ds. So ds is the surface to that double integral, that del cross F, that is curled into the vector. Then the third step is to circulation of a vector field around C equal the integral of the curl of the field over S. See, in this the circulation of a field around C equal the integral of the curl of the field over S. See, in this Stokes theorem we are using in the various places, that particularly we are using in the closed surface C and the surface integral of the curl of a vector field. That is very important. Then in this integral over F vector into dr is that double integral over S, the del cross F vector into ds. Then application of Stokes theorem. See, in this application of Stokes theorem, fluid dynamics, electromagnetism and statics. See, in this fluid dynamics, related to the fluid flow around a curve to the verticity of the fluid. Understand vortex motions in fluid. And electromagnetism. See, that related to the circulation of a electrical field to the change magnetic flux using Faraday's law induction. And then statics, that we calculate angular momentum and torque essential for the understanding rotational dynamics and the physical systems. So that is the very important usage of the Stokes theorem applications. Next class we have to see that the various things in the Stokes theorem, Gauss divergence theorem and the Green's theorem. Thank you.